Oh, I can leave now. Okay, so what we basically did, this is our, well, maybe I should show you the slides first.
Yes. Maybe you also want to say a little bit about the course.
Yeah, the course is a beginner's computer graphics course, and we are primarily teaching Java and
I think programming course, not computer graphics.
It's computer graphics. We have small, very, very, very tiny parts of real computer graphics, not computer graphics, computer science. Did I say computer graphics?
Yes.
Yeah, I mean computer science, of course. It's a programming course, and we do some graph theory and stuff like that, but it's primarily about teaching them how to do basic programming in Java. That's the most part. And so what we built is this. So this is our slide deck, and maybe we go to the graphs. Thinking this is just a presentation framework for JavaScript, where which we generate obviously from HTML, which is, I told you, we have annotations, but those annotations are basically links to other chapters. And of course, we have annotations by the means of HTML. We use certain classes for definitions and stuff like that. So it is structured. I'm not sure if it's consistently structured all the way through, but there is something. That's actually not the one that was boring chapter. Very interesting one. So more things can happen. So you see, we have source code there where we can step through. This is currently it's tailor-made, it's manually made. What is highlighted, we're working on a solution that can generate that stuff using a debugging interface that can build all the steps where you go through the programs and show what the output is, what the memory is looking like, and stuff like that. So students get a basic understanding of how programs.
Something like that. It looks so good.
There is a debugger, interactive debugger, which there's a basic version which I've used intensively, and they have now a more intensive one. Being able to tie to the debugger visualization for non-trivial data is not something that we have. Hence, a little mini application I showed with the for graph theory class.
We'll be using this one, Python tutor. It's from MIT, and it's also working for, well, obviously other languages. And so it's pre-generated. It's not on the fly because I don't like that it slides because things can go wrong. It will generate a set of data, and the slides will just play them back, basically.
And so you are using Python tutorial.
Sorry?
So you are using Python tutorial for this?
No. We're doing Java. Currently, we are not. We are using the Java. We will switch to Python, the course, because Java is, well, it was never a good language for beginners, and still isn't. And when we switch to Python, we will use Python.
I prefer C++ for beginners, but it's my take. And it was for what Java. It was for what beginners.
Yeah, Java has, especially for non-computer science, it's just a okay. It's the first thing is, I'll tell you this, but you won't understand. I will tell you in 3 weeks, and this you won't understand either. You have to do it, but I will tell you in 5 weeks. And stuff like that.
The more you have to say something like that, the worse it is for beginners.
Yes, and it is
just write public static void thing.
Just remember this and write it. We will explain what these words mean to you in a while.
It's a magic incantation.
Yes. That's not good. That's why we are switching. But switching is we have built a lot of infrastructure around Java, and we have to change that infrastructure now to Python, and that is a lot of work. And,
Have you considered standard ML instead?
Actually, no.
Actually, not a bad idea.
I know. I'm very much in favor.
Yeah, it's hard to tell. I don't know what a machine Bauer is in English. But the mechanical engineers, it's hard to tell them why they should learn a language they cannot use in practice.
Fair.
And then they cannot use in practice.
The thing is, when you have like a language like Python, some people will have already worked with it and some people will not. And that creates a very uneven playing field. My university started with Pascal, which nobody had done.
And I totally agree for computer scientists, which have to abstract language anyway, but here we have to teach a language they can use in their studies. And that's the problem. That's the problem we have with Java, because Java is taught in some schools. It's in Bavaria. It's the language that is taught in a school if the school is teaching computer science after a certain grade. And so we have people that can actually they're very good, and we have absolute beginners, obviously, and this gap we always have. We have it with Python a bit less because actually school is not messing it up.
Okay.
So if they learn Python, they learned it because they were interested. So those are mostly better students, but we have some that have a fundamentally wrong understanding of Java and object-oriented code, because, well, some teachers just, well, they learned them themselves very fast back 10 years ago, and not very good computer science teachers. And there are a lot of things wrong with some of them, and those gaps we try to eliminate. And basically with machine learning, I know it's from this community, it's hard to say, but the other departments here at the technical faculty, for them it's a very important field, and that's a field that's played in Python currently. So it's a very important language. Yes, so we have interactive elements that are, as I said, handcrafted in our slides. Just so you get a bit of feeling of how our slides are working. We also have, I'm not sure if this is because we're not using it anymore, with the kind of lectures we did in the last 2 years. We didn't use everything here. We can program in this stuff. I'm not sure if this version supports it, but we can edit these code snippets and execute them in the browser. That's what we have built. It's a framework where you don't have to install Java, and we are transpiling Java code into JavaScript code and then run it through the browser to have the results of small, tiny.
You're reinventing Jupyter.
We are reinventing Jupyter because Jupyter did not do Java. That's absolutely right. Yes, and we're yes. Jupyter is a great format. It does a lot of things just right. And we had to build this from scratch again this is just the slides we built for our learning platform, which is an Ilias brand. Ilias, I'm not sure, most people don't know it. It's something like Moodle, which is more known. And we have to build something where students can program in this learning site and stuff. And this is very similar to Jupyter Notebooks, obviously.
Are you considering switching to Jupyter for?
I did consider switching to Jupyter. We have a bit of a different approach to how things are handled in our set, because we're doing exams and stuff like that. We need more, but I was thinking about implementing Jupyter Notebooks for our Studon or Ilias, so that people can create notebooks online in the system.
Oh, that is interesting, because especially interesting because in CDE we are currently thinking about having a teaching installation for the whole university of Jupyter.
Okay, that would be great.
That would be a synergy.
We currently we are using something that's called Iodide, which again is Iodide is something I just said for Java. It's a transpiler that is an actual Python environment that runs in the browser. And you can install Python packages there. It has Jupyter inside of it. And this would fit in our currently built infrastructure with our system we have. We can easily bring Jupyter that way in, and it would run in the browser of the students, basically, which is not a native. It behaves like a native version. It's much slower, basically, because it's transpiled code, it's WebAssembly code. But it brings the advantage you don't have to maintain server-side infrastructure, which is important for us because we're doing exams with it, and with exams with 800 students, which is a test for our infrastructure, let's say it that way. So we like to run it in the browser because you don't have to install stuff server side. That's basically a big advantage.
And there is currently a nice convergence between Jupyter and Pyodag
Okay.
with Jupyter Lite. So now,
Yeah,
when you install,
I
you
read
have a
that.
version of Jupyter, which is just Jupyter Lab, but meant to be run in the browser.
Okay, that's basically okay. So maybe we don't have to implement that ourselves again. We can just reuse it and just have to deal with the Ilia stuff to integrate it. That would be great because maintaining this stuff
Is a pain.
is a pain. Yes, it is. you know. So okay, this is a slide deck we have.
I'd be curious to see what the sources look like.
Yeah, you see, this is where it's served from, and we have a compiler that is building our stuff from templates. Okay, this is just the structure of our slides, and I'll show you a real editor now. Slides. We've structured it we'll include in our chapters. So these are, we just looked at the graphs chapter. Maybe I should open this graphs algorithmics. This is our code. Yeah, we have each slide is a section. We've annotated stuff. Those are things that are where you can click through. I'm looking for some source code. There was something. You can see we had these images that you can step through. This is basically how we build them. There's a JavaScript file that describes each stage of these animations and puts them into place. This is something students do not see. And well, I guess I can't show you more about our source code. This is basically it's plain HTML with some. Go to the real graphs chapter. There are some definitions in there. I guess there are some definitions in there, which are basically just a class name that's added to it. What we bring this all together using a content file, which is basically just including certain chapters from this HTML into one larger chapter. And our process is, as I said, it's very simple. There is a special tag that is a chapter mark where you can reference other chapters in the thing, which is basically an internal link that is resolved when we compile our slide set. What you see here, this is the source data, and it will generate these HTML files you also saw previously. This is the actual HTML that is generated from these sources, which is a very, 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 this is nothing special. Okay, this is a very basic template system where some placeholders are replaced with the correct data and some libraries that are loaded to make it all work together. And some data is parsed on runtime, like the data for the source code examples and stuff like that.
I would just like to briefly introduce Michi to
Right.
Frank Bauer. He's showing us his
Slide framework.
and computation framework, which is kind of the FAU version of the talk you heard from Nicolas. No, we do not. I wanted to tell you about it, but the interesting thing is that Frank is interested in using Jupyter for teaching, and in his thingamajig, and Michi is the person gradually looking into setting up the Jupyter. So and I had earlier said, well, we are doing this. That's the guy to talk to.
Okay. Yeah. So data is, well, human structured, like there are these for every chapter, the names of the chapter, the slides are assigned to certain, well, this is basically our sub chapters we have, and then within each slide has this its own section, which doesn't always have a title. So there is no, the annotation we have is basically what we needed for a working slide set for students to quickly jump to another slide. This is the problem I was describing in the beginning. We always have links to look up chapter 5 if you're interested in that, and to automatically generate them, because obviously where this types chapter is placed then is not known when we build it. That's the only reason we have this, and that's everything we have.
Cross-reference resolution.
So is this,
and we're building this also something very trivial. Yeah, this table is also built from this.
you're doing, so there's two questions.
Yeah.
Are you using, is there a kind of a cross-course subsection sharing? You're not doing that.
Because our students, well, when we did that, our students didn't have any cross courses in informatics, in computer science.
Right, but you might actually have the section that's
Yes,
also in
that's-
some other course of yours.
Exactly. No, they don't listen to any other course of ours as well. This is a singular. That's
No.
Subsection of the slides.
Yes.
Is whether
sorry, yeah.
source actually source sharing. You might actually have something that might come up in, I don't know,
Yes.
UBGS or those kind of things, and you could just compile. You're compiling a course from sources, and now the question, of course, is, do you do it like LaTeX, where you basically go through every course and have another big zip file or something as the output, or do you have separate compilation?
Separate compilation. Correct.
Okay, so you have a
This is-
compilation and linking phase.
This is a self-maintained repository. It only knows this slide deck, and it can compile only from this slide deck. I mean, basically, it's just a folder structure. Okay, if you're adding a second course into that folder structure, it will discover the other course as well, and will link to those, and will output different HTML files for two courses that can connect each other. It's because it's so very basic. It's not a problem to have that. Yeah. Not sure if that was the question. I guess
I'm not
so.
sure whether it is either, but we can talk about that offline.
Okay. They can share, yeah, where the links lead. That's
No, I was
Okay.
actually, so one of the things I always, for every course I give, I have essentially the same admin slides.
yeah, we don't.
Um,
Because my courses are so very different for different studies and stuff like that. We don't share slides basically.
Okay, good. Then the question is meaningless,
That's
essentially.
Yep.
I'm very proud of actually having a reuse factor of 2
Yeah,
in my
that's-
slides.
well, we have this course, the Introduction to Computer Science, that has the mechanical engineers, electrical engineers, and stuff like that. They have a completely different set of organizational slides, because everything is managed differently than in our other course, like the DH module, where we have only the DH students and a very different approach to tutorials and stuff like that, which
Okay.
is it's fundamentally different.
Okay,
Basically. So there, at the moment, there was no way of sharing data. This is our system. We use it for this lecture and this lecture only.
okay,
And,
good.
and it was derived from when we first took over this lecture, it was a set of LaTeX
Mhm.
sources, and the one that changed it made PowerPoint slides out of those LaTeX things, which are not modular, so we couldn't change. Yeah, and that's why we devised this system, because we wanted the modularity of the old LaTeX, but we didn't want to use LaTeX because we wanted something interactive.
Yeah, sure.
Yeah, and this the whole thinking behind this project is basically it's based on this. We want this modularity. Yeah.
Yeah.
So just to give you the idea
I think
what's it.
That
it's
helps
not-
me understand things
doesn't-
better. Yes.
Yeah, it doesn't have anything to do with representational semantic stuff. It's all just means to an end so that we can get it to work. But we didn't think about anything special that we can structure it. Yeah.
Surprisingly similar to what we have, where we did think about
Yeah.
doing semantics. I think, yeah, it's surprisingly compatible, I would say.
Just out of curiosity, this is using reveal.js for
Yes.
this slide.
A very heavily modded version of reveal.js because we integrated the entire handling of source code and stuff like that. This is an additional library we added into Reveal, so that because at the time we were doing this, I think this is 2015 or something like that. It was basically just these fragments you can click through. And again, with the source code, we didn't want to build for every step the custom HTML manually. We devised the system where we can input some semi-structured data, and these click-through scripts you saw in the slide deck. I think we can see that better. Yeah, all these things and stuff like that. This is automatically generated from something where we can say take the
Can we see
seventh letter.
Can we see the source of this slide?
Let's find them. My naming seems maybe a bit problematic. Because this chapter should be called methods, but it's basically let's see if I can. Chapter 5 and chapter 5 is including calls, obviously calls. Here, and I think it was this is a data box, we call it. This is on line 1 on character 22, and then we show this hint Eingabeparameter.
So, which allows you to keep the code just as plain code and audible.
And the newer system we are building up right now, when this is again because we had certain videos, we have to use our slide deck from 2018. We were building a system where we can annotate this in code, so we don't have to put these numbers in, but just have an annotation in the code that this is a class name, and then it can generate these numbers basically from the code, which is a pre-process. It's just running through the code and putting in the correct numbers again in our compiled script, and it will then in the compiling phase it will output something like this. This for example here is different. Those are annotations, and we can also annotations as well. And this is something else where we can step through the source code and we see things happening, like the robots appearing or showing the output from the program and stuff like this. This is also done with the structure. We know which step is which line and which stage the output is changed into, which is basically a stage is a definition. That's HTML source lower down right here. Those are the stages that are connected, and that's simply the image sequence that is stepped through on the lower right corner right here.
Okay, so it's the animation is not is built separately from the code. It's not as a result of the code.
It's not result of the code, because at the time when we were building this, we didn't have the framework we have now, where we can run code in the browser. We had code execution on a local server that was running, and then the slide set was communicating with that, and it was hard to implement it graphics basically like that. That's why we did this. The new version will do this as well, because well, we like to have pretty deterministic results in the lectures, so we are building it beforehand and compiling. We also had something we call the Blackboard, which is basically a code editor we can open in the slide deck. Ooh, it's so long that we used this in a lecture hall that I don't even remember the shortcut. But it's basically just a big window that is taking this code snippet right there, and then you can execute it. You can change it and execute it in the browser and show not graphical results but textual results, but what's output on the console. And those are the beginning examples. So we have a lot of images in the beginning to hook students into following the course. Later on, it's more basic text output and stuff like that. This is a definition. It's the next slide right here, which I hope it was done the right way. Yeah, this is basically a definition include style define, which for us is okay. We having a definition here, and it's coming from this call source. So this is what I mean here. It's done the way that we can include them and can easily change the definition to a different language or something like it. It's easily replaceable, but there is no semantic data what this definition is about besides the headline right there. But
right, so let's can you increase the font size a little bit?
Yeah.
Nice.
I'm sorry. This one.
Okay,
This
you're
call
using-
source is definition HTML. There are different definitions in this file, and you can reference which one is included now in this thing. And our definitions, well, okay, they're HTML formatted because I wanted to have the liberty to change anything I'd like. There.
I'm not sure what I'm seeing right now. That's the target for the definition include.
We look at this. This is the definition we are showing right now.
Okay.
And this definition is in this file. It's basically the second line here.
Mm-hmm.
And this is referenced from our code with this data include.
Mm-hmm.
I'm actually not sure why this is in a line break tag. Okay. Well, okay. And we say this basically tells us the layout in the slides should be a definition, which is this red box. We have different things like that, and we are using the second line again as the second line in this file, and it ends in the second line of this file. And whatever is in those lines in this file is included as the definition in this thing. So that's what I mean. There's no semantics. It's just second line. That's the definition you should put in there. The only way you get semantics in there is, well, if you read the text, but it's not.
That's perfectly fine.
Okay. Right. And what you can also see this ref tag. That's the one my compiler basically parses. This references class components. You see here a section can have a label or something like this. Section is called calls.dot, which is referenced from other parts. And this one will generate the chapter mark you can see here to chapter 12. Okay. So it will find the source file where this label is in and check in which chapter it is embedded. And the first embed from this is then put here, and links are generated appropriately.
/pagerank.
Yeah, and basically, yeah, exactly. We have to do it this way because we need to find out the chapter. And as you can see, it's not writing which chapter it is. This is the entire HTML is generated from that, obviously, because
that's
I don't want to retain it.
Right. That's what Tech also would do.
Yeah, exactly. And it is again, it's just tends to mean, we have these annotations manually in there, and then we change chapters, and you will miss at least one.
Yeah, sure.
Yeah, and it's wrong, and so we had to find something which automates.
Yeah, that's. I mean,
it's the basic.
That's the only way you want to do it.
Exactly. Yeah, that's this framework.
So what we're seeing here is a special source HTML, which is compiled into a presentation HTML, and the presentation HTML is probably one big HTML file or some collection of smaller ones, we don't, with lots of JavaScript and all the necessary bells and whistles and some anchors that you don't want to write. Good. So my current assumption is that your source HTML is somehow equivalent to our STF, or has a non-empty intersection with. That's what I mean with somehow equivalent.
Don't you know that this doesn't seem to be XHTML, which is this?
No, this is XA. I'm a web developer. I'm not doing XHTML. Which I know. This is it's what I said. Yeah, it's not. That's not the idea behind it. The formal. The idea behind it was a working thing.
Right.
And the students work with the HTML online, or do they have an offline version of it?
We provide both. We have this version you can see here online. They can use it as they like, and we also can generate a PDF version with it. From it, there is a special. You might have seen it. And I don't think it works. Safari is very bad at printing stuff, but there's a special layout mode that generates pages, and if you print those, that's the Safari problem. It always assumes a certain file size, but you get one page. If you print it with Chrome, you just have the slides things, and so this is a fixed set. When there is interaction on a slide, you might have, probably nobody will notice this on first glance, but there is, if you have something you can change when clicking through and you don't say something special, then the last stage is output to the PDF. We are not outputting every stage of the animation, but only the final one. You can have an annotation right there when you don't have the final one in the result, but there's only every slide from the HTML translates into one page in the PDF. Mm-hmm. So we're not unrolling them or stuff like that. Students like the online version more.
Obviously, yeah.
Obvious reasons. Yeah, but some want the printable version.
Yeah,
people still print slides.
What brings me to my next questions? Do you use an analytics tool like Google Analytics or Matomo to track which slides are mostly viewed? Because we need something like that for our flipped classroom, I think. That's probably interesting.
We have access to the server logs, so we can probably extract the information which pages or which slides are viewed most. But that does not include which we could see the chapters that are called, but then the entire slide deck is loaded, so we cannot say which slide in the deck is viewed and something like that, because that is a pain to have at the university for a mandatory course. I'm not sure if your slides have that, or if you need that.
When you say a pain in terms of RGPD and
it's hard to implement. We would have to offer a version that does not have the tracking, basically, because people have to
be able to opt out. Yes.
So
those are things we will have to worry about in the Volkswagen project.
Yeah, it's something we can build in. We have obviously something we can build into something like that, but we have to maintain two versions. People have to consent to use the tracking one.
Yeah. Is it two versions, or is it?
No. So
could it be just one version that's using a cookie, say, on the tracking?
It could be. I'm not sure how we would implement it. You'd have to, for me, I would just simply have two repositories, one without every tracking data and one that has the tracking included. And depending on the URL you're using as a student, you're getting the one or the other, because this is for me less likely to have some mess up in the code where the tracking is enabled, whilst the student said I don't want to have it. So I would separate it. And with
But
the
since you're
compiler-
compiling the
compiling,
result
exactly,
anyway.
it's just another template that you're compiling where the tracking is in and off, and well, a different URL. That's not
Well, it's just for the student, it's slightly different model. So now students are used to say, yes, I want cookies, or no, I don't want cookies.
Yeah, I would,
Obviously.
that would be some, and well, we are.
Also, which means when you give a link to your students, oh, go see this chapter, we have to link to one of the other versions.
Here we go. New brilliant interface. So I'm not having to type my password, but you know I have a very old name from our center. And this is our course right here. So this is the students view, maybe not the last week, but this is the slide index I showed you in the beginning is just for me, basically for the one selecting. The students see this, which is also generated from our data, which is the chapters for each week associated with the according video we have. This is the link to the interactive online slides the students get. This is the PDF version, and we also have small tests, something for self-learning and stuff like that, which is collected right here. And when we would have two versions, we would basically preface this view with a question if you're agreed to tracking or not, and then the links you're getting right here when you click on it would be to the one or the other, yeah, or something like a checkbox on top. And so yeah, students would still have to agree, and if they don't, they get the plain version. And if they do, this link would change to something.
Dennis, Domi, remember that we want to steal this for KI. I think we'll already solve quite a lot of our promises. We'll integrate this into Studon.
I did write it down 1 minute ago.
Okay.
Well done.
It's really nice.
Work. Your compiler builds a HTML chunk that you can include into.
This is a pain because Studon does not allow custom content. Well, custom HTML content, it allows custom content, but it's very tailor-made. What you can do is include it. You mean this view, right? You can include an iframe. So the server that is serving our slides also has this special timeline HTML, what you're seeing here, which is included as an iframe into Studon.
Okay.
Yeah, because Studon doesn't do this. I have this half. You see, I have a lot of half-ready things because I have this half-ready interface for Studon, so that you can add this view to any course and don't have to have a server. But well, time is my limit. So.
Absolutely, yeah. But I think this is something we really should take into. We should really because we actually have ILI as a kind of informal partner, and they're supposed to do things like that.
Well, I am not sure what the formal partner is doing, but
they have actually funding for things like that.
okay.
Only they told us we won't find anybody who can do this.
That's
Why don't you actually employ somebody?
Yeah, okay, that's what I was trying to say. We have this cooperation as well.
Mm-hmm.
And we were in this process. They really have a problem finding people. Ilias is written in PHP, and you have to write PHP plugins. And I know this because I did this. So I still am one of the guys that learned PHP. But today you won't find very many students that do PHP.
We still do train some students to do PHP at our university.
Yeah, well, our students hate it basically.
Yeah.
It's-
And they're right.
I don't want to either.
Yeah, it's a, but this really you have to do PHP. It's the only way. There's no JavaScript or something. They're serving the entire page from this is plain HTML.
I know.
Can't they
iframe is
implement
actually-
Ilias from scratch?
Yeah, you see what they do when they re-implement Ilias. You have a gray bar you cannot hide anymore. So this is the newest version of Ilias, which looks like a design from. Okay, maybe we stop hating Ilias.
Like Moodle.
Yeah. Yeah, and they don't have any content. So the fact that this iframe is in, I'm not sure if this will be a persistent solution, because when we change to our new Campo management and student is taking a more important role in managing modules and exams and stuff like that, they might take this out because they fear that you can introduce harmful code. It's an iframe, you can't basically, if it's done properly, but well, this might be a feature that is removed for future implementation. I don't know. Yeah.
Will it make a big difference for students if they are brought to a distinct page?
We had that before. Well, this is our page. Well, the time. This is where the timetable is applied from. Basically, we have some metrics there. Students are lazy. They don't click through to other sites. What they don't find in Studon is mostly not there. We had some extra content on this page, for example, for students to prepare no, this is basically this is our Jupyter implementation. This is our online Java code execution environment we're having here, and it also does Python and Java, obviously JavaScript does as well. And this is what our students should work with. This is linked from our student course, so that it's integrated for them. They can access it to write their own code and stuff. But most things they're doing, they will do in this environment.
So for exams,
we use this, what you're seeing right here. This is the version we're using to do our exams.
so everything is happening in the browser, and then there is something sent back to the server at some point.
During the exam, the answers people, well, this is not a code question. This is basically, this is our code plugin used as something to bring interactive content into Studon tests. So we first implemented our code plugin, which is
Wait, this is inside Studon.
Exactly, and you can do stuff like this. This is programmed in JavaScript, and it's injected into the Studon because we're using our source code plugin, which allows us to change the DOM of the during runtime, basically, which is some sort of a backdoor into Ilias, which is acknowledged by the Ili team. It's all okay, but if you have to do some interactive content, that's the way you want to do it. Right here, and what there's no real source code question in this example. When students do program here, we're just sending back the text they're programming or the solution. Then we have a student interface which can download the entire exam. So it's basically a folder for each student, and every question the student did answer. And then we have some offline tools that do the automatic pre-assessment and stuff like that. Then we manually check everything. Have a special file where we put in the comments and the points. We upload it to Studon, and then the exam is done, which is the only way we can do it, because our code runs in the browser and it's Java. We cannot do an automatic assessment. And well, actually we can. I sent you the link with it, again, with a different system, not with this way, but when students upload a Java file to a tutorial, there is a backend server that is automatically evaluating the uploaded code and automatically generating the points without any needs for manual download and stuff like this. But this is a different kind of system. Student has so many different systems to do tutorials or exams or stuff like that, which is not integrated well. Basically. Yeah, I can show, maybe I can show a real programming. Programming test. So this is one of our programming tests. They can make. So basically, it's probably very simple, but I have to read what we are going to do. I think we can add a player right here. Loading world player. Execute this. You see this pink player was added. This is our code execution. It can interact with the DOM, and it runs the student code in a web worker so that the student code is separated from this learning environment. They cannot change it, they cannot access it, which is important. But the code that's generating the visualization and stuff, this is something I'm writing or the lecturer is writing, and they have complete access to the student DOM, which is again a tiny bit of a problem, but yeah, it's accepted. There would be better methods to separate the lecturer code from the HTML as well. We cannot implement it due to the way Student is generating its pages. We cannot do. Don't remember the name, but there is some scoping possibilities in the HTML DOM or stuff like that. Student doesn't allow this. Basically, it's overwriting the appropriate statements. Yeah, that's our way of doing things. This is separate. The code that's generating this and is running here, this is something we add to our slides. So we have interactive slides.
Yeah, thanks a lot.
Yep.
Sure. It was a lot.
So you're all your integration and front end stuff is very impressive. I'm actually interested in the sources.
You can have them. This is all. It's not in a public.
No. I'm actually interested in adding to the sources.
Okay.
Preferably
Sure.
small annotations. To be honest here, I would be interested to co-develop something that would give us use the tools we're developing,
Sure.
thereby like creating guided tours or those kind of things, and giving a carrot to you to add semantic annotations in your own code.
Yeah.
Right? And if you could show the definition again.
Find it again. Yeah, in this part, there was no definition.
And I think the annotations that would be needed would be relatively small.
Again, it sort of depends on how deep we want to go.
Yeah, right. But I
just similarly as with like Vue and
exactly
books, like in a first iteration, we probably only need to know this thing depends on this.
Exactly. So
that would be the most.
No, not that definition, but the thing where
We'll tell you that we already broke everything we say.
Yeah.
Right. So here.
The most annoying thing would be parsing the sources because they're not XML.
Well, you can put them through tag soup or something like that.
Yeah, I have
tag
a
soup is horrible.
Or just
Type.
do like what we were thinking yesterday. You don't worry about this. You do the parsing, we provide you a database.
Yeah, that's,
And then stuff.
that works for Jupyter. I don't know if
Well, they have a
yeah,
process- they have a processing
there's
tool.
always a way around
I mean,
it.
they have a processing tool in the way. They're already
Yeah,
parsing.
we
Oh,
are
right.
parsing- we are parsing this HTML, so it is parsable.
Oh, yeah,
We're
that's
using
true.
Node.js to parse it. But it is parsable.
Yeah.
So the thing we were thinking of yesterday was that we were starting from Markdown files, JSON books, and there's a conversion process, and then so adding annotations, and then in the conversion process, compiling, regrouping all the annotation information into a single mini database, and then we could just fetch the database and think from there. So nice thing being that if we do agree on which, if we all agree on the format for the database, you can use your loop chain, I can use my loop chain, and we can both use there.
Right. The things that are interesting here are mostly these kind of things that you have in B tags.
Well, that's like
No,
the
about
second layer already, right? But in the first
Like,
iteration, we
okay,
don't
okay.
even need to know about those.
And then the bold text.
yeah, bold tags. Yeah,
That's a place where it's currently
Yeah.
not semantic.
Yeah.
yeah. That's what you're really there. It's either I would say definienda or references to defined terms, and having those marked up.
We'll see. I mean, again, it's the things that we want the students to know about this.
Exactly. So those are the content
Yeah.
terms,
Yeah.
and they're defined somewhere, and they're used in lots more places. And if you make those just like you have semantic references in there already, right? If you have a semantic, it's essentially a semantic label ref-like thing, which is slightly more complicated, but that's something we know a lot about.
Yeah.
And then you can, and that would be the main thing that needs to be marked up. And together with something like begin definition, end definition, which kind of gives us the scope of what depends on what. And then that's already, and kind of, what are the snippets, right? You want to connect into a guided tour, and what are their roles, didactic and semantic roles. We mark those up, and I would suspect that's kind of a 10%, 15% more work
No, that's
thing. We can actually get the guided tours mechanism to work with this.
so basically, in my terms, as a non-expert, those B tags, the definition text, and the example source or stuff just need some connecting label.
Yes, exactly.
This is the dot operator's definition.
That is
Some
that,
connecting label, and if you use it, something that references the label. Yeah.
Right. And that's something we would have to develop. And you would need, your compiler would need to be extended by essentially making SMS files.
Something like that, yes.
Right. And I think that would be relative. That's just an old technology. Ancient technology.
Basically,
Did we just get rid of those?
yeah.
We did.
Something easily parsable XML JSON that basically just contains the kind of information that we're interested in, and then we can use that to like represent all of your course slides basically as one giant theory graph, and from there we can just select nodes and do guided tours from that.
That shouldn't be a problem.
Ideally, cross-connect them to other theory graphs, like for example, Nicholas' Jupyter notebooks or Michael's AI or EVGS slides, and then have all of those be cross-referenced. So if there's something like, okay, I know what a graph is, but I don't know what an acyclic graph is or something, like if that doesn't happen in your slides, it could just link to Michael's notes.
And you can learn it in French.
Yeah, or you can switch to French. Or
But and so that our goal in the project was to just basically build a huge domain model, like harvest a huge domain model from your slides and my slides and Nicola's slides and have a huge knowledge graph and learning snippets graph for all of computer science.
Basically, the global FAU theory graph plus Paris plus, I think currently it's right.
Yeah.
So, but
if it works with Jupyter Book, then it can spread.
Yeah.
Oh, we
yeah.
use quite. If you pick some Jupyter Book extension,
yeah,
it's
and
Jupyter
people
Book is-
actually use those properly. Then at some
Yeah,
point, we
also-
have like all our friends as a theory graph.
Well,
all of French computer science using Jupyter.
well, many outside of American. But it would be actually interesting to see if even if just by using Jupyter Book or some interesting data can already be harvested.
Yeah.
This without annotation.
You can also see this as the equivalent of Wikidata for teaching materials. It's also a way of characterizing what I would like.
And maybe it should not be analogous, it should be the Wikidata. Eventually Wikidata being
Could be.
increased.
I mean, the simplest thing is going through one of those sub slides and doing the annotations there and see where it takes us.
Exactly.
If it's enough, I can change.
And then you also know what the investment would be.
I mean, as I said to you, the idea of generating an index is something I never had. It's a great idea, and it needs some.
That would be a side
organization for
effect,
me.
yes.
And exactly. And I like that idea for the students. So this is something I want to do anyways.
Better than actually generating an index, which is kind of a very dead tree concept, would be to generate something that's sometimes called knowles, which essentially if you have a reference to a certain term, basically you hover over it and then this expands by showing you the definition and those kind of things.
Yeah, like the next step after index is basically glossary, and that
Right. And that is a kind of an inline glossary, a modern glossary, and all of those things are doable there.
And we also, this is something we currently maintain manually, is talking points for our questionnaire, like this. Okay, I mean, there are some things that are not related to the lectures, but this is something we can generate if we have special annotations there. So I don't have to manually do that each time because this is a manual list.
Yeah.
And
Also, what we can
Like
do
maintaining
already
lists.
from our STEC sources is generate kind of a graph. I think you've even seen this at some point.
really?
Richard did this.
Okay.
So you have the kind of the domain model as a graph, the concept graph and the dependencies. And you can color that graph. I'm currently where the red part of the graph is those things we still have to cover.
Yeah.
The green part of the graph is what we've already covered, and the blue part of the graph is the things I haven't told you, but what this depends on.
Yeah.
And that gives you a relatively good overview if your screen is
Sorry, not
large enough. And you can then zoom into this.
Probably using mind map software can help. These mind map software are meant so that you can see just a piece.
Possibly, yeah.
Something like that, where
But-
you can focus into what you're actually doing and see it branching out.
Yeah, but mind map software really blows up for things of our size. It's just my AI course has a couple of thousand concepts.
I mean,
Where-
we have to make it manageable for those are all beginner students.
Yeah.
Here's what I'm going to learn.
Yeah.
1,000 concepts.
And this is just one lecture.
Well, I mean, you can like nicely categorize them by chapter and section and stuff, and then you can go into there. From there, you can generate the guided tours, which gives you like the backwards. So there's ways to like handle the size of the graph.
We have these representations, and we know which chapters we're referencing from others. So a very easy representation would be to have a small graph right here where you can see which other chapters are
Interesting.
this subject, which would be accessible for students because it doesn't have this mind-boggling big tree of things you have to know. It still looks manageable. We have to, with our students, we need to watch that we do not discourage them. Most of them don't want to learn science.
No. I know why.
Battery?
It looks like battery. Yes. I just plug it to you.
Yeah.
Yeah, that would be a way, or I have a power bank.
Yeah, okay. So
I think that might have more interaction. This is much better.
Having too good a fee structure would scare the students.
Yes, some of our students are in our evaluation scared of this list I show you the overview of the chapters. We have very small chapters, but a lot of them.
Yeah.
And they are all computer science. That's so much work to do. Where the other profs have like 10 slides and you have 40. And this is you're doing so. And then they're small. Yeah, I do one slide deck in 20 minutes without questions. There are questions, of course. So this is not much we're asking, but they are.
Think about biologists. Each slide is 100 words that you have to run by heart.
Yeah. Well, yeah.
Connect to Jabra C510. Go to the Bluetooth menu on your smartphone and select it from the list.
Of the graph. Yeah, only if somebody really inquired. That was the basic idea. If you assume that this chapter is branching out, then why not just show the branches that go out from this, the first child from this. This is a manageable amount. You see that there is connected stuff, that there's other things to come. You see where you land when you click on it, but you never have this whole entire large graph, but only this small. This is just expectation management for our students. I'm just thinking about when I generate something, what would that look like?
Yeah. I mean,
it's not in principle or good for anyone else. It's just for our lectures. Yeah, I think that also just requires experiments. Yes. How many connections can the student follow in one go without losing plot? Well, this is the representation of our. Well, this is the current representation of our lecture. It's everything you have to do in 1 week, and you can see the others if you chose so. You can click through the entire course if you'd like, but you're always only confronted with this 1 week, which is a manageable set of input. And this works very well. Students like this form of representation better than the other way, where we have this complete. I can show you the old way. The old way was basically what the system does provide us, which is this section here, where everything is it's sorted by weeks, but it's still a long list. And students didn't like that. They didn't understand how to manage a week. I don't know why. Okay, it's basically I don't understand, but it's the feedback we got when we only had this. It's very confusing. It's so much stuff you have to see, because it's not only this one. You also have your exercises, which is right here.
Yeah, the week-centric thing is much better. I can see that.
And the other is it's the same information, but in a very condensed format. They prefer that. And as I said, this is just for our lectures. It's not in general
what do I need to do now? What do I need to worry about now?
It's exactly what our students expect from us. Yeah, I'm having some time now. What to do next? And this is still the format.
We learn maybe not to go into a rabbit hole.
Yeah, I mean they have to learn at some point to manage themselves, but we found that that's not the case. So.
Yeah, you have students who are very, very new and young.
Yes.
Also, I'm still learning to manage.
I'm forgetting how to.
I'm working.
I have to put out a timetable for it.
And it's also a time of life where we have maybe so that's first year, second year students, I guess.
Yes.
That's the time of life where you have the highest number of different courses. Because before you had math, physics, blah, blah, and so.
Sure.
And then you have all the different specialties. And later on in master courses, usually you have 5 courses. And each course is going to take 1.
And
So
there are students that they discover they are not interested in their studies as a whole. There are students that they see us as an optional. We are not. We are to take our courses, but they see us as an optional, so they don't invest many times because they didn't want to study computer science. They want to study something else. So it's different from a master's course, where students are more involved and they want to do this course and they engage with it and do stuff. We have to feed them a bit to take them to bring them in.
Also, of course, in the first 2 semesters, students don't even know how college works yet. They don't know how lectures works yet. They don't know what's important or what isn't, or everything is confusing and everything is stressful
And this especially this we developed when we switched to the online courses, where there wasn't the university as the institution there. You were at home and you have to manage yourself and all your courses. So we wanted to give them some guidance.
Yeah, I did something very similar for my AI lecture, where I basically manually prepared their calendar. Right? It says read this, this, and this, and we're going
that
to talk
we did
that.
as well. There is a calendar module in the Studon. We did that too. That didn't work either because some people didn't know how to view this calendar in the interface and stuff like that. It is the onboarding problem.
Sure,
I know it's the bit, but it's the way we do it.
It's standard university problem that there's so many platforms with, and everybody does calendars, everybody does this and this. It's very difficult as a first semester to get an overview of it all.
We should develop a standard that covers everyone's needs.
Yes.
Insert XKCD.
Yeah.
No, but I think the general problem of having a really rich knowledge environment available, which may be very useful, but could also be a distraction from the thing you have to focus on right now, is much harder.
But this is an interface problem. I mean, this is only driven by the front end. This confusion. You can have all this rich data in the background, but you have to manage it for the users in the front end.
But yes, I mean, knowing what will be the right amount, that's what I imagine.
right. And we as the teachers are not exactly helpful, right? Because we compete for attention. And of course, my course is more important than yours or yours or yours. So I'm going to make everything blinking so that they don't actually veer off into Frank's courses. Right? We're not necessarily trying to be helpful or optimizing.
Each lecturer sees its own lecture.
Yeah.
We have to teach our students our stuff, so we have to enforce that they're doing our stuff. We have to make them interested in our stuff because we're competing not with other lectures, but with
the rest of the world.
The rest of the world, basically, and as I said with this, I mean, YouTube videos about teaching computer science are probably more engaging and exciting than my lecture. I get that. Well, yes, they have there are some, not all of them, and not the ones that are produced by other universities, but from interested channels, they have a budget for a 20-minute video we don't have for 5 years. They're producing high quality content, and it is high quality content.
Oh yeah,
But there is no guided tour.
Yeah,
It's just-
exactly.
and they have these speakers who sound exactly like Sendung mit der Maus, right?
And they can focus on subjects that are very interesting. You have to teach boring stuff as well at the university, because you have to, someone has to do that. And so, but we are competing with that. And the more we go to, in my opinion, the more we use digital platforms and stuff like that, the more we are competing with this. So we need to bring something to the table that is more a connection of. That's what I like this part. It's connecting things you do not get when you're watching a YouTube video. YouTube is suggesting you something, but it's not a connected, knowledgeable thing.
It's also not user adapted.
Yes.
I mean, all the tutorials I see on programming on the web, most of the Python tutorials are a little bit better, but they start 2 steps of where I would need to be collected, right? They're using a couple of things. If I had a guided tour for everything, then I could actually use them. Without something like a guided tour, I'm completely lost because I do not understand the first sentence.
Yeah.
If I understood the first sentence, I would probably also understand the second one, but I don't.
Or the opposite happens and they start too early and you skip through the thing and then
And then I come out at the wrong end. Then
exactly. And then you're at the place where you don't understand anymore.
My experience with programming tutorials on YouTube is usually that I only encounter them if I look for a solution for a very specific problem. And then what I find is a 15-minute YouTube video with 20 calls of actions and 2 ad sections before somewhere in there, there's like the one sentence that I actually care about.
That's the drawback of this. Yeah.
And with a blog post, I could just do Control F. Like
this is a general problem.
Yeah.
Is it these guided tours, are they planned to be course specific or
Topic specific, I think.
What do you mean? What's the topic in this case?
Give me a guided tours on DPLL in SAT. So.
Yes, okay, but that does that incorporate any elements from one course that takes that, or because otherwise
since MMT is the thing that generates it, MMT ultimately pretty much doesn't care. It just cares about connections between nodes, and where the node comes from doesn't matter. Like MMT doesn't even know which archive something comes from. But you could, of course, add.
You would eventually. We will actually need to show people as much material they've seen or should have seen as possible.
Yes, but that can come from different places, right?
Yeah, sure.
We were talking about how everybody competes with each other before. So, like, if one student has problem with your teaching voice, for example, and you two both explain the same thing in different parts of different courses, you could also send the student over here. You could even include some of these high production value YouTube videos for the things that are interesting and then are.
Indeed. And therefore, user modeling, so preference modeling and competency modeling are the 2 things that are most important. Right? We can generate guided tours until we're blue in the face, but if those are not tailored to the user, we can almost just forget it. I mean, in principle, every YouTube video is actually a guided tour for an imagined user. The problem is I'm not that. I'm pretty far from that imagined user. Sometimes I'm close to the imagined user. That's a good video, or good for me. And so the guided tours just need this user model in the background, which basically tells us about the whole thing here, is that not only do we need semantic annotations, so guided tours can only work if we have a good domain model. That's what we're talking about. But also, we need to have all these little phone home widgets, which basically says, Frank has looked at graphs. Frank has now done an exercise on graphs. Aha, Frank understands graphs. And then, oh, now he's looking at union find algorithm. And oh, yes, that's good because he understands graphs already. But oh, dang, he doesn't know about equivalence relations. And so on. So this modeling that we're doing all the time, right? I mean, if I'm seeing this discussion, my user modeler is running hot, right? Saying, well, we've talked about all of those things. Jonas probably remembers that because it's only half an hour past, so I can link back to
there.
right. That's modeling, making assumptions. And so that's really one of the missing components. We need to integrate all these, or we need to instrument our generated HTML with loads of calls to the user modeling component. Right? We need to kind of report all of the, if the students opt in and so on, all the click stream, all the solution, the grading stream, and so on, and do it on a very fine-grained level.
Point being, ideally, the actual knowledge graph, theory graph, whatever, is fully interconnected across all courses, and like everything is connected with everything else. But if you're looking at a topic of the AI course and you're a student in the AI course, the user model probably should prompt the guided tours generator to preferably use material from the AI course, because likely other people use different notations, possibly. If they don't use STech, we can adapt the notation.
As long as you have, as long as you still have such things as discrete courses, because you don't need them if you
in the university you need them, because at the end you have to have an exam and like a piece of paper that
they will be there
boring.
Yeah,
they will be there for some time.
Yeah,
So you can reuse this material so that on top of the existing material that is anyway developed for courses, you can have overuse it.
Well, if you
can also have guided exams if you think about it, but that's
oral exams are guided exams, yes.
not exactly what I was going for, but yes, you could. I know that it's still necessary for now, but if we dare look into the future, it could be very interesting at that.
Well, you could. I mean, you could have students who ran through the Volker-E-based education at FAU. At the end, there is a relatively detailed competency model. They could just export that and give it to their employer.
I don't think most students would like that.
No.
we could also encode it on the blockchain.
I mean, I'm not sure what that would show about students if they want to know it for themselves.
Right, but I mean, then you could actually, if you trusted these methods, you wouldn't need exams anymore.
Exactly, it's my point.
Which would be wonderful because it would be bad for students because they have to kind of perform at every point of the way, which is, as we know, the most effective.
For students.
Huh?
That's good for students, both for their learning and for and just for their well-being in general. Because what's stressful about universities is usually that you do work for an entire semester and then it all comes down to 2 hours. And if you slept badly that night,
I don't agree. There are students, they find that very stressful if they're under permanent testing.
Yes. This would be kind of the permanent testing for every single waking minute.
I agree totally with your point.
Yeah.
The lazy students, it's a good thing that they're doing continuous work and not just stress learning and stuff.
But you need forgiveness so that at any point, if you haven't done it before, you can make up.
Yeah.
Oh yeah, absolutely.
But the part in this representation, if it does not only include computer science, it would also solve problems for lectures like mine, where we have to tell the mechanical engineer why they're, for God's sake, learning our stuff. Why do they have to learn about graphs?
Yes.
We have to build this connection to their subjects, to
Yes.
their lectures, why they have to. If you
Just
have
a
this representation,
look
it's
at all of these
exactly.
modules that need that.
And if
Right.
you want to, if you're interested in this part, you need to listen especially carefully to this part in our lectures, which will help us legitimate the stuff we are doing.
Right. This would not be like guided tours are backward looking.
Yeah.
And then motivations are always forward looking inside the same, say, discipline. Whereas what you're saying is kind of building application bridges, which are sideways looking. And all of those things can be done automatically, yes. That's one of the things that actually drives me in all of this.
More interesting aspect when it comes to that is that at some point we're going to have to talk to like mechanical engineers and get their lecture notes and have someone who actually understands mechanical engineering.
But that's something we're doing in EVGS, right? That's something that Jonas is doing very well in his homeworks, right? So that all the yeah, not the mechanical engineers, but having hieroglyphics and Edgar Egyptologe and so on, and that's really what we want to eventually have automatically. Yes.
Yeah. I don't know if the idea of using hieroglyphs to do that can be done by a computer, or it needs someone like Jonas saying, "Hey, this would be cool for the students." It can be annotated,
yes,
that makes it easy to find.
But Dennis has actually built a viewfinder that can, in principle, do that.
There are tasks you have to do in these disciplines where you can backtrack it to what do you have to learn in our lecture to do this. Yeah, you have to know what a loop is, for example.
Yeah.
It's basic things. It's not research. It's just the fundamental thing. Why would I have to learn how to do that? Because I want to do something like this, and it's hard for. I mean, if you're doing it for long enough time, you probably know what to tell them. You need this because of. But if you're getting a new students, when we started this lecture, we didn't know what to tell them. I don't know why a mechanical engineer needs to learn programming.
I remember the physics student in the topology class asking the lecturer why topology is important. They were stumped.
I mean, it's basically for computer science, it's the same. You have to know the basic stuff as an engineer today. You need to have an example why, because students don't believe you why.
Yeah.
You should know that.
Yeah. Normative answers are not very appreciated. Constructive answers are. Good. So I think if I may partially summarize, otherwise I'm going to use the L word again. Yes. We've learned about what you're doing. We haven't helped you at all with what we're doing. But I think we have a much better understanding now, and I would like to thank you for coming here and showing us. And I think we probably want to spend the time with Nicholas doing the kind of equivalent thing that it would interest you for his stuff. And then based on what we do there, I don't know, talk again next week and and kind of fill you in of what the extensions would be for you, and then maybe do the analogous harvesting thing, and maybe building on examples that we're doing with Nicholas this week. But I think it's very valuable to know what you're doing and all the wonderful things we can steal if you let us.
Not stealing, it's all university stuff.
Yeah.
With one caveat, and that being that probably starting next week, I should focus on Weichenfeld stuff so we get the guided tours. But then it's even better because then we can immediately do something with your stuff.
Exactly. That's
Yeah.
exactly what we're, I would say for the new semester, we might even already be able to show things.
That's interesting.
I'm certainly hoping for guided tours for my next lecture in the next semester, which is a couple of days after Weichenfeld.
Yeah, okay.
Yes.
Like 4 weeks or something?
Yeah.
In the next 4 weeks.
Does the HTML have to look nice?
No.
Okay.
No.
Yeah, then I'm
Nobody
confident.
cares. But if the browser is rendering it.
It's rendering something. It's not that bad. Some math might still look ugly.
That's fine.
Yeah, for this question of personal data protection, do you imagine that with proper pretreatment, you could actually, let's say, compile the guided tour thing so that it could be run locally on the student's machine and just use data that is only on the student machine and never ever?
You would have to
train it. I have something.
Yeah, you would have to run the user modeling on the user's machine. That's not what we're currently envisioning, and that's, by the way, not quite what we want, right? We will need, so essentially the dependency relation, we want to, at least that's the current idea, to compile into a essentially Bayesian network, some kind of a graphical model. And the structure of this, basically the graph of the Bayesian network, should be doable. I think we just have to sit down for an afternoon or two and see what this actually all means. And then the problem, of course, is a Bayesian network not only needs the graph structure, but also the conditional transition tables. Conditional probability tables, right? Those we are going to need to establish those. We will need kind of aggregated cohort data. Right?
So you need
How-
to train.
And
There
these
will be
need
a
to be,
training
yeah, we need to have a full Bayesian learning or some approximation of this algorithm to actually learn the conditional probability tables in the Bayesian network. Once we have those, and we need data for that, we can actually compile this into something that might run on the local machine. But the bootstrapping is, and then we might actually eventually, in the kind of final, ask students to donate their data in an anonymous way. That's what I would eventually like to do.
Say cookie pop up in front of you and you have to click yes, whatever.
Right.
The other thing about running guided tours locally is, of course, that you lose a lot of functionality. Because while a guided tour is, of course, like basically a sort of self-contained, ideally it has lots of connections to the outside. So at some point, either you have to like just cut off and say, okay, if you're now interested in what a topology is, you have to go back online. Which kind of defeats the point of having it like self-contained, or you have to put more.
By self-contained, only you mean self-contained in terms of data that it needs.
Right.
Yeah.
So that's
that would also be difficult, I think, because you really the user model data is on the big graph, which is all of computer science, and that might actually be pretty big. I don't know, but that's something to be considered.
You could do something like dump a guided tour, a fixed guided tour into like a locally downloadable fragment, which would then be static and just be isolated from the whole thing. Which is
the user.
You're barking up the wrong tree.
Yeah.
So our current design is
it
that
would,
we have
it
this
would
massive-
just really be
no,
isolated then.
No,
That's
no.
the bad thing.
No, still, I haven't made the point I want to make, that Nicolas wants to make. In our current setup, we have this user model server, which has all the user models of all the students, which is a huge security risk, right?
Yeah. Okay. Yeah.
Now,
So
the
that-
question
that
was,
part, yeah.
can I do it decentrally? Ideally, with my user data being just a little file on my laptop.
That comes with its own danger. Have you ever heard about this? I was at the Starbucks cafe and somebody stole my laptop with all of my master's thesis on it.
Yeah.
That would be the same thing.
Right.
Imagine-
And a disk crash would be, well, you lose all your teaching learning credentials.
But those data, that doesn't have to be stored locally. It just has to be stored in a way that only you can access. You can send it to a server, you can encrypt it,
But
so you won't lose it when you lose your machine. If you lose your machine, nobody can access it because they don't have the access tokens and stuff like that. There are solutions for this. The question is if you can model your user, if you can model the system with something like you have this bulk of intermediate data that's derived from anonymous input from all the users and your data set, your personal, fully complete data set. And there are, I'm not sure if this is a real term or if it's just marketing, that's this differential privacy stuff.
Yeah.
Thing. But it's hard to.
We've already been talking to the Rechenzentrum people to like get this on a like secure thing somewhere where our students can only access it with their FAU credentials and like.
Yeah, but that's not that's actually cryptographic.
Yeah.
Centralized thing, and ideally you would be data frugal. It's basically not actually have the data under somebody else's control. Right? Privacy by design.
Yeah.
And that's what this differential data privacy is.
Okay.
I mean, right now we have to do lots of chin-ups to convince people that only I can use my data, even though it's in the central location.
Yeah. Okay.
Is kind of the wrong approach. That's what I think was Nicola's point, which is exactly the right point. I'm not sure we're the ones to solve this. If somebody else solves it for us, I'll be very happy in the next iteration of this to do it.
Probably we don't need, it's not for us to solve practically, but designing or how the machinery works to enable this, we have an influence there.
Yes. The question is whether I want to kind of put it on the critical path or not.
No.
My answer is
No.
I don't. But yes, when it's developed and ready to deploy, this is one of the first things I would think about.
Although it's somehow in the critical path, in the sense, if we get a first thing which even maybe are not that of little quality, but don't require to start experiments to do all the RGPD, blah, blah, blah. So for example, so here the difficulty is the training part.
Yes.
We need access data to the training, but can we do guided tours that, okay, won't use the training, or will be?
Yes, but nobody will
doing
want to use them.
Well,
symbolically can you do, or it's just by.
I mean, I can scroll down until I find the stuff that I don't already know. Like,
No, I mean, it's using my data, but it's not. It doesn't need to be trained with others' data.
I'm not sure.
Even just,
I'm kind of still hoping.
even just tracking dependencies, the thing knows what I've already worked on.
I'm kind of still hoping that once I wrap my head around these kind of compiling into Bayesian networks, that we do not that the conditional probability tables are actually trivial or generatable. So could just be that they're all noisy ands or something like this.
Or at least in the first approximation, it's already useful, even if it's not the full board.
Right. Indeed, that might be the case. I haven't thought enough about it. And yeah, if that is the case, if I do not need to train the network or learn the network, then that would be fine. And I think there's a certain hope that this is indeed the case. And then I could do the like local things and
do experiments in 3 weeks, well, let's say 3 months from now, and our students play with something.
We're going to do the experiments 3 weeks from now with synthetic user models. That's what we're aiming at. Just easy, just if you have the graph, do a kind of user model, make a user model by just counting down 7 levels. The competency is 0 for the first 7, then it's 0.5 for the next 5, and then the rest is all competence 1. Those are easy to do. We can demonstrate what they are by having for different synthetic user models, you get different guided tours. That's enough of a carrot, I think, to dangle in front of students to say, well, this is cool, I opt in. And that's what we need for the project. And we'll get a couple of early adopters. We will get their data, and then we can see from there. And then kind of refine the design from there. At least that's my plan. Lunch?
Yes.
Yeah. So, bye-bye, Dominic. Thanks to Frank.
See you.